So today with this video we're getting started with chapter 13, and we are simply continuing with solving equations. Chapter 12 could really be summed up in that we focused on solving one-step equations. So, in other words, in order to get the variable by itself, we only had to do one operation to both sides of the equation, and then we had our answer. Chapter 13, we're sort of advancing to two-step equations. And so, in other words, there are two operations that are happening to the variable on one side of the equation. So our first question is we are given this equation, 5x plus 3 equals negative 7. So earlier, before chapter 12, one thing we were doing was evaluating expressions. And when we were working on those, we would be told what number to replace the variable with. So for instance, in this case, we were told maybe x equals 1. And so we would take 5x plus 3. We'd plug in 1 for x, and so we'd write 5 times 1 plus 3. Oh, put my parentheses in the wrong spot. Parentheses should go around the 1. And so, with respect to the 1 now, there are two things that we have to do. We have to multiply by 5, and then we have to add 3. And according to the order of operations, please excuse my dear Aunt Sally, we start with parentheses, grouping symbols, and then we work our way down. So to evaluate an expression, we go down the list. And so the first thing we run into is multiplication, and then the second thing is addition. So we say multiply by 5, add 3, and we get 8. Alright, and as you can see, if we plug in 1 for x, we get 8 on the left hand side, which doesn't equal the right hand side. So obviously x equals 1 is not our solution that we're looking for. So other than guessing and just plugging numbers in, we want a better way to find x, or to get the x by itself. And when several operations are happening to the variable, what we do is we simply work our way backwards up the order of operations list. So we can say to solve, we go this way in general. Now, in some cases, just as when we were evaluating expressions, there were some exceptions. There will be some exceptions to solving equations, but typically we take care of, or we undo addition, subtraction first. Then we undo any multiplication or division that is happening to our variable. Then we work with exponents, and last, grouping symbols. So for right now, just to get used to doing things backwards, we're going to talk about what is happening to the variable. Okay, there were two operations, and what were they? Multiply and add. Okay, we multiplied by 5, and then we added 3. Alright, So we're simply just going to write out a list of what we did. So what's being done to x? When we plugged in the 1, what was the first operation that we carried out? Multiply by 5. And you have a 5x here. So x is being multiplied by 5. Multiplication comes first in the order of operation. So we would multiply by 5 first, and second we would add 3. Now, these are not the steps that we take to solve the equation. This is simply what's happening to our variable. And in order to solve our equation, we have to reverse this list and undo each step. So at the top of the next page, we have a list of what is being done here on the left, operation being done. If we add a particular number in that list, then to reverse that we subtract. So we're just simply listing the operations with respect to undoing them, the opposite operations. If we subtract, to undo it, we add. If our variable is being multiplied by something, then we divide. If our variable is being divided by a number, then we multiply by that number. So here's a different list, and it's related to the list that we just filled out. Again, we had the list 1, 2, multiply by 5. This was the list from the previous page. Add 3. So what we're going to do with this list to solve for x, this list was what is happening to the x. To undo that, we're going to work backwards up this first list, undoing each operation. So if we go backwards, the first step we run into was add 3. Well, how do you undo addition by 3? You subtract 3. So we've undone this operation. Continuing backwards up our list, we run into multiply by 5. How do you undo multiplication? Well, you divide. And to undo multiplication by 5, we divide by 5. And this is our list of the steps we need to take to solve the equation and get the variable by itself. So I'm going to fill out my list again. Subtract 3, divide by 5. So here's our equation that we started with. 5x plus 3 equals negative 7. And to work out the steps that we need to take, realize that we only considered this side with the variable, the 5x plus 3. The negative 7 didn't play into formulating our steps at all. So when we say subtract 3 is the first step in solving for x, that means we take both sides of the equation and subtract 3. What you do to one side, you have to do to the other. So when I subtract 3 from the left, the plus 3 and the minus 3 cancel, and I'm only left with 5x on the left, and negative 7 minus 3 gives us negative 10 on the right. Here is our second step to get the x by itself. And so here we wrote a fraction bar underneath both sides because we want to divide, and we divide by 5, so we put a 5 underneath the left and the right. On the left, the 5 simply cancel out, or in other words, 5 divided by 5 is 1x, and 1x is the same as an x by itself. We don't have to list the 1 in front. And now on the right side, we actually get our answer. Negative 10 divided by 5 is negative 2. If we plug our solution back into the original equation, left hand side, we have 5 times negative 2 plus 3. Negative 2 times 5 is negative 10. If you add 3 to negative 10, you get a negative 7, which equals our right hand side, negative 7. So negative 2 is our solution to this equation. So once again, to solve an equation, we simply work backwards according to the order of operations. We undo addition and subtraction first. Next, we would undo multiplication or division. And then in the end, if there are exponents in parentheses. But for right now, we're just, in this chapter at least, we're only dealing with really multiplication and division, addition, subtraction. So it may come naturally to you to know what to do to solve for the variable. If that's the case, then by all means, don't worry about writing out a list according to what's being done to the variable. But if you find yourself struggling, this is a good way to fall back on and get yourself on the right track. Alright, what's being done to z? Well, we only look at this side with the variable on it. According to the order of operations, the z would be multiplied by 4 first. Sorry, my pen is acting up. Once we multiplied by 4, we would subtract 11. So, if I were to just pluck this expression out, 4z minus 11, and just pick a number at random, it may or may not be the solution, but if I were to plug in a 2, how would I evaluate that expression? Well, I would first multiply by 4, getting an 8. And then I would subtract 11, and I'd get a negative 3. But obviously negative 3 doesn't match the 29. So I didn't pick the solution, but the point is, what happens according to the order of operations to z? We multiply by 4, then we subtract 11. Alright, and that makes our job of figuring out what to do to solve for z easier, because now we have a list that we can simply work our way backwards up the list, undoing each step according to the opposite operation. So working backwards up this list on the left, we run into subtract 11 first, and we want to undo that. So I would say to undo that, I would simply add 11 to solve for z. And again, the goal of solving these equations is to get the variable by itself on one side. So once we add 11, that undoes the subtraction of 11, and continuing backwards up our list, the last step we run into is multiply by 4. To undo multiplication, we divide. So we would say divide by 4 to get the z by itself. And now we will simply carry out this list of instructions on both sides. Add 11. So I align the 11s up because the whole point is so that these cancel out. I've got a negative and a plus. It's just sort of a bookkeeping practice. The 11s cancel. Here I wrote 11 on both sides just to show that I'm maintaining the integrity of the equation. I'm doing the same thing to both sides. So the 11s cancel out on the right, and I get 40 on the left. I bring down the 4z to the next line. I rewrite my equation, and now I sort of start over again. I have completed the first step in my list, and now the second and final step says that I want to divide by 4. So I simply write a fraction bar underneath the left and the right hand side, place a 4 underneath each, because what I do to one side I want to do to the other. On the right, it should be obvious that the 4's cancel out. 4 divided by 4 is 1z. So, not really having any room below, I'll go off to the side. There's my equal sign. On the right side, I'm left with a z, which is the goal of solving an equation. And on the left, I have 40 divided by 4, which is 10. If you return to the original equation, replace z with a 10, and we're simply calculating the right hand side. 4 times 10 is 40, and if we subtract 11, we get 29, which matches the other side of the equation. 29 equals 29. So z equals 10 checks out as our solution. Another example at the bottom of the page. What's being done to w? Well, first it's being divided by 4, and we're only looking at the side with the variable on it. We would divide by 4, and then we would add 7 according to the order of operations. To create the list that we would use to solve for w, to get the w by itself, we work backwards up this list, undoing each step. The first step that we run into going backwards up this list is add 7. To undo that, we subtract 7. So we are undoing all of these steps working backwards. So we've taken care of addition with subtraction, and the final step that we run into is divide. So over here in this list we would write multiply by 4. So here's our equation. First step is to subtract 7 from each side. I simply like to write the operation, the step, underneath the equation. You see that the 7's cancel. And on the left, we have a negative 10. So we have subtracted 7, and the last step on our list is multiply by 4. And I will write that by simply putting each side, left and right, in parentheses, and then outside the parentheses place a 4. On the right side, the 4's cancel. And so on the right side of my equal sign, I would write a W. And then on the left side, I do the calculation. 4 times negative 10, and I get a negative 40. If I take that back up here, to the original equation and replace W with a negative 40. And since I'm evaluating an expression now, I follow the order of operations from P to S, PEMDAS. No grouping symbols, no exponents, but we do have division. So negative 40 is divided by 4 first, and we get a negative 10. The next operation on the order of operations list is add 7. Negative 10 plus 7 is negative 3. And we see that the right hand side works out to match the left hand side. So W equals negative 40 checks out. Alright, here's one of the exceptions to working backwards up the order of operations list. If we go backwards, you might want to say we undo the addition of 7 first, but that doesn't actually happen. That's not how we solve this equation. And remember that when we were working down and we ran into a large fraction bar, we would carry out operations on the top and bottom first separately. So the exception working down the list was a large fraction bar, and likewise working backwards in order to solve an equation, the large fraction bar is once again sort of an exception. So here we sort of need to stick to the method of asking ourselves what is being done to the b, and b is our variable in this equation. The b is only located on the right hand side of the equation. So if I had b plus 7 over 4, and I just picked a random number, I'm not trying to pick the solution. If I just picked a random number and replaced it with b, which operation would I carry out first? Well, large fraction bar means that I work the top and bottom separately. So I would add the 7 first, and then I would divide by 4 to get 2. So our steps would be add 7, divide by 4, reverse the list and undo each step. I would write multiply by 4, subtract 7. So these are the steps that we will actually use to get the b by itself. I will transfer my equation down here. My first step to solve for b is multiply by 4, so again I put each side, left and right, in parentheses like that, and then I put a 4 on the outside. And I want you to see that there is a 4 on the bottom of this big fraction bar, and then we're multiplying by 4 on the outside. So what's happening is we're multiplying reciprocals here, so to speak. The 4's are simply going to cancel. We don't actually want to take the 4 and multiply b and 7. You just want to realize that this 4 in the denominator and the 4 outside multiplying the fraction are going to cancel. And so on the right side we would only be left with the b plus 7, and then we'd actually calculate the left to get a negative 12. And I'm simply just rewriting that so that I'll have some space below, because I have one more step to get the b by itself. and that would be subtract 7. On the right side, 7's cancel, b is by itself, and to calculate b, subtract 7 from negative 12, negative 19. So be aware of the large fraction bar. It's an exception to working backwards up the order of operations. Looks like we have another one in the next problem. So what's being done to x? Well, if we look on the top, large fraction bar, we work the top first, and so we say multiply by 3. Then on the top you would add 2, and finally we carry out the division of the large fraction bar, divide by 2. So to reverse and undo each step, first step we would undo is division by 2, so we'd multiply by 2, check. Then we want to undo addition of 2, so we would subtract 2 in this list. And our last step to undo would be multiply by 3, so I'd write divide by 3. So here's our steps that we need to perform to each side of the equation to get the x by itself. Parentheses around left and right hand side, because the first step to solve is to multiply by 2. And again, notice that there's a 2 on the bottom of the fraction that I'm multiplying by 2, so I just want to cancel these 2's out. So that leaves me on the right hand side just a 3x and then plus 2. On the left hand side I have a negative 4. The next step in solving my equation is to subtract 2. These 2's cancel on the right. I'll transfer my equation up here, and so on the right all I have left is a 3x, and then on the left negative 4 minus 2 is negative 6. So I've completed the subtraction by 2, and at this point this is just a one-step equation. We worked a lot of these in the previous chapter. It's probably obvious without looking at the list that to get the x by itself we need to divide by 3, because the 3 is multiplying the x. We want to do that on both sides. So there's our x, and negative 6 divided by 3 is negative 2, and so there is our solution. Once again, great thing about equations is, yeah, they can be a little difficult to solve sometimes, but you can always check your solution by simply going back to the original equation, replacing the variable with the number that you believe to be the solution, and then evaluate. At this point we want to follow the order of operations. Alright, straight down the list. Parentheses, exponents, multiplication, division, addition, subtraction. We are evaluating an expression. There are no variables here. We've replaced the variable with a number. So first thing we do is we multiply negative 2 and 3 to get negative 6. So we multiplied. Now we're going to add on top. This division was skipped because that's a large fraction bar. It separates the top from the bottom. So we divide in the last step and we get negative 2. The right hand side matches up with the left hand side. Negative 2 equals negative 2. and so our solution checks out. And we shall continue to the next page. Solving equations with fractions. Fractions are very cumbersome to deal with. To add or subtract, you need a common denominator, and then when you multiply two fractions, you have two numbers to keep up with, a numerator and denominator. And so with equations, we sort of use a cheat tactic. We can simply get rid of the fractions. We still find the lowest common denominator of all the fractions, but we use it a different way. We don't replace the denominators with the lowest common denominator. We simply multiply the entire equation by the lowest common denominator. So here we have denominators 3, 4, and 6, and the smallest number, lowest common denominator of 3, 4, 6 is 12. So, what exactly did we do with the 12? Look at the bottom of the page. And we have written the equation. So here is the left-hand side. In these parentheses, we have the right-hand side. And we see that the left and the right-hand side are in parentheses. What is on the outside? The 12. There's the 12. There's our lowest common denominator. We didn't use it as a denominator. What we're going to do is multiply both sides by 12. And what's going to happen is that the denominators are going to divide evenly into the lowest common denominator. That's why it was the lowest common denominator. This number 12 is divisible by 3, 4, and 6. So we distribute the 12 here on the left. 12 times 2/3 x, and then minus 12 from the subtraction. 12 times 1/4. Then we take the denominator underneath the 2 here, the 3, and we transfer it over underneath the 12. Likewise, we take the 4 of 1/4 and we transfer it underneath the 12. Then we take the 6 of the 7/6 and put it under the 12. And now 12 divided by 3 gives us a 4. 12 divided by 4 gives us a 3. And 12 divided by 6 gives us a 2. So no more fractions. The fractions are gone. So with any equation that contains fractions originally, we multiply both sides by lowest common denominator, and we get rid of the fractions. We don't want to deal with them. They're difficult to add and subtract. Well, maybe I shouldn't say difficult, but definitely more time consuming. We take these new factors, 4, 3, and 2, we multiply the parentheses, we get 8x minus 3 equal negative 14. This is much easier to solve than the original version of the equation with the fractions. So what do? We undo addition subtraction first, and we have subtraction of 3, so we add 3 to both sides. 3's cancel on the left, we bring down the 8x. Negative 14 plus 3 is a negative 11. Then we divide by 8 on both sides because that's what's happening to the x. X multiplied by 8, we undo that by dividing by 8. What we do to the left hand side, we need to do to the right hand side. And so in the end, we get x equals a negative 11 over 8. And you could plug this back into the original equation. Plug it back in for the x, the variable. Now we calculate this. 2 and 8 would cancel because we're multiplying, so we can cross cancel. We would have a negative 11, 1 times negative 11, and then a 3 times 4 on the bottom, 12 for our denominator. So negative 11 minus 1/4. Now we need to fool with the denominators because this, we're evaluating an expression. We're not solving an equation in this case. So we need to use the denominators in the usual way. 12 will divide into 4, so we'll use 12 as our common denominator. 4 goes into 12 3 times, so I multiplied this fraction by 3 on both the top and the bottom. Negative 11 minus 3 is negative 14 over 12. Each of these numbers is divisible by 2. And so 14 over 12 reduces to 7 over 6, which is exactly what we have on the right hand side. So our solution checks out. Alright, example 4. We have an equation with fractions, and before you start sweating and worrying about getting the denominators equal and adding, subtracting fractions, remember that there is an easy way out of dealing with the fractions, and that is to multiply by the lowest common denominator on both sides. That will knock out the bottom numbers. So, question is, lowest common denominator of 6, 3, and 9. Let me think on that. 36, I believe. So, I'll use 36. We could actually use any number that's divisible by 6, 3, and 9. Wouldn't hurt us too much. We'd just end up with an equation with numbers that are bigger than what they needed to be. So I take left hand side in parentheses, right hand side in parentheses, and I place a 36 on the outside. I distribute. There's 2 items in this set of parentheses, so I would write 36 times 7 over 6x. Bring down the subtraction, 36 times 1/3. We already have it set up on the right, and we simply just say 9 divides into 36 4 times. So instead of writing 36 and 9, I put a 4 on the outside of the 5. That becomes a 20. If you transfer the 3 underneath the 36, that's what you're doing. You're dividing the 36 by the denominator. So 36 divided by 3 is 12. Then again, feel free to write this step out, but you're simply taking the denominator and dividing the 36 by it. So 36 divided by 6, 6. Don't forget about the x. Bring that down along with the 6. And now we're not finished. We haven't solved the equation yet, but this equation is going to be a lot easier to deal with. So what's happening to the x? We multiply by 6, subtract 12. To undo those two things, first step would be to add 12. We want to get rid of the 12, so we do the opposite operation. We can't just simply add 12 on the left, we have to do it on the right. 12's cancel on the left. We bring down the 6x. 20 plus 12 is a 32. The 6 is multiplying the x. We do the opposite and divide by 6. And then we have to divide the right hand side by 6 as well. 6's cancel, leaving a 1x. 6 divided by 6 is 1. 32 over 6 doesn't go evenly. Both are divisible by 2, but this is our answer. Now I'll simplify it. 32 divided by 2 is 16, and 6 divided by 2 is 3. I could write that as an improper fraction, but it is simplified. And then I didn't have to write this 1 in front of the x, so I could just write it as an x. So in the end, x equals 16 divided by 3. Another equation with fractions. Smallest number that 4, 8, and 2 will divide into is 8, so I multiply each side by 8. I can rewrite this as 8 times negative 1 fourths x. I'm distributing the 8. Then 8 times 7 over 8. On the right side, I would say denominator divided into the 8 would give me a 4. So instead of writing 8 and 2, I write a 4 out to the side of the negative 3. For this product in the middle of the equation, the 8's would simply cancel out, leaving a plus 7. Negative 3 times 4 is negative 12. Here, if we transfer the 4 underneath the 8, 8 divided by 4 is 2. So that would be 8 and 4 gets replaced by 2, and on the inside we would have a negative 1 and an x left. 2 times a negative 1 is negative 2. So this becomes negative 2x. I'm just going to rewrite the rest of my equation. No more fractions. So now I can focus on getting the x by itself. The first thing I need to do is subtract 7. Bring down my 2x. The 7's cancel, plus a negative. On the right, negative 12 minus 7 is negative 19. My x is now being multiplied by negative 2, so I divide by negative 2 on each side to finally get the x by itself. On the right, the best I can do is say that the double negative rule makes the 19 over 2 positive, and I'll leave this. as an improper fraction. And so my solution is 19 over 2. So example 5. Here we have an equation with decimals. Alright, and the right hand side is the side with the variable. So the first thing that happens to the variable is we multiply by -2, and then this 27, which I'm glad we have this equation in the workbook. This is important. The 27 is positive. We could say this is a positive 27. And so what's happening is we're multiplying by -2, and then we're actually adding 27. So to get rid of this 27, since it's positive, we would subtract it. Alright, so you look at the sign in front to decide whether you add or subtract, not the one behind it. So on the right, the 27.8 cancels. We bring down the -2x. 2.2 minus 27.8 results in a 25.6. Now we focus again on the variable. Well, it's being multiplied by -2, so that means we do the opposite and divide by -2. Transferring my equation over to the right, the 2's and the negatives canceled on the right, leaving an x by itself on the right hand side. And then what is 25.6 divided by 2? I bring up my calculator, and I've already calculated 25.6 divided by 2. We get 12.8. And you will be happy to hear that for the remainder of the test, you will also be able to use your calculator. It was just this first test where you weren't allowed. So the two negatives give us a positive, and we get positive 12.8 for our solution. Example 6, you have to read it carefully, but we are given an expression and we want to evaluate that. What is the value of v plus 2? Well, we don't know what v is. We need a number to place in there so that we can add 2 to it. Well, to find that number, we need to solve this equation. So this is sort of a two-step problem. First we solve the equation and find v, then we insert v into v plus 2, and we will then know the value that they're looking for. So, focus on the side with the variable. Undo addition subtraction first. With a -9, I want to add 9. 9's cancel on the left. 6 plus 9 is 15. Now we see that we have v is being multiplied by a 3. There's only one operation that's happening to the v. 3 times v. How do you undo multiplication? Well, you divide each side by 3. The 3's cancel, and v equals 15 divided by 3, which is 5. So now that we found the number that we are supposed to replace v with, we can evaluate our expression. V plus 2 equals 5 plus 2, which is 7. This is the value that we were looking for. Example 7. Here we have an equation with parentheses now. So what we'll do is we'll walk through the list of what is happening to x. Alright, so if we didn't have this equation, this equals 62, and we were focused on what is happening to the x, well, according to the order of operations, PEMDAS, we would carry out the operations inside the parentheses first, P. Inside the parentheses, we have x times 4 and then add 7. The first thing that happens is we multiply by 4. Once we multiplied by 4 and we had a number there, we would add 7 to it. So the second thing would be add 7. And finally, once we added 7, we would have a single number inside the parentheses, and then we would multiply by 2. The 2 on the outside of the parentheses. And we came up with these steps by working our way down the list. Now, what do we do to solve for x? Well, we had 3 steps on the left, so over here we're going to have 3 steps. We're just simply going to work our way backwards up the list and undo each step. First step we need to undo is the multiplication by 2, the 2 on the outside of the parentheses. So opposite of multiplication is division. So we've undone that last step. Next step we have to undo is addition by 7, and so we subtract 7. And finally, undo multiplication by 4, we divide by 4. These are the steps we need to follow in order to solve the equation, get the x by itself. So, first step is divide by 2. And we put fraction bars underneath both the left and the right hand side. On the left, the 2 on the outside cancels with the 2 that we placed underneath. The left hand side becomes 4x plus 7. The right hand side becomes 31. So we've completed the first step. The second step is to subtract 7 from each side. The 7s are going to cancel on the left, leaving only a 4x. 31 minus 7 is 24. So we've completed step 2, and now for the final step, divide each side by 4. The 4's cancel on the left, leaving an x by itself, and 24 divided by 4 is 6. Here we are with the last page of the chapter. We are given a new type of equation, and you can see that we have 2 variables with an x. According to the previous chapter, 2x and 7x, which are on the same side and are being added, are like terms. So in other words, we simply add the 2 and the 7, and we place an x behind it. 2 plus 7 is 9, and so the left hand side would combine into a 9x, a single term. We'd simply carry down the 45 on the right, And this is one thing that is going to pop up in a lot of equations. You want to combine like terms. Now that we've combined like terms, we just have a simple one-step equation. X is being multiplied by 9, so we divide 9 on both sides of the equation. 9's cancel on the left. 45 divided by 9 is 5. And here we are with our solution. X is by itself. If we plug that back into the original equation, 2 times x would be 2 times 5 plus 7 times 5. 2 times 5 is 10. 7 times 5 is 35. 10 plus 35 is 45. And that does equal the right hand side. Example 9. Linear equation with several occurrences of the variables on the same side. So here we are with a 3y and a 4y. Again, they're being added. We simply add the coefficients. These are like terms. Same variable y with the same exponent 1. 3 plus 4 is 7. So we combine these into one term, 7y. Everything else is going to tag along. We bring down the minus 29 and the negative 71. And now we proceed in the steps that we need to take to get the y by itself. Add 29 to both sides. 29's cancel, leaving a 7y on the left. 71, or a negative 71 plus 29 would be a negative 42. 7 is multiplying the y. We refocus on the variable. What's happening to it? It's multiplied by 7. The opposite of multiplying by 7 is dividing by 7. And then what you do to one side of an equation, you want to do to the other. So we divide both sides by 7. 7's cancel on the left, leaving y by itself, which is the whole point of these steps. Negative 42 divided by 7 leaves us with a negative 6 for our variable. And that completes chapter 13.